All right, so the random variable x has the following distribution, right? As we said, random variables, this can take any values, all right, depending on the experiment. They can take any values. And these are the probabilities attached to these values of the random variable, all right? So we've been told find EX, which this means this is the same. This symbol means the expected value, basically, all right? So let me get the formula for the expected value. Here it is. So basically, we're going to multiply each of the random variables with their probabilities. So we're going to say 1 times 0.25 plus 2 times 0.25 plus 3 times 0.5. So let's say 1 times 0.25, that is 0.25. 2 times 0.25, that's 0.5. 3 times 0.5. So it will have 0.25 plus 0.5 plus 1.5. And that is our expected value. It's EX 2.25. Right, we go to our second one. All right, they've told us to find E5X. So this is the general rule we have to follow. All right. This is the rule you have to follow when you're doing such questions. All right. E A X, right, is equal to A E X. Basically, we want the expected value to be separated so that we can find it and then multiply it by the constant of A. So I don't know why Microsoft Word doesn't want the A should be in small letters than the X in capital letters. Similarly, even here. All right. So basically, here, let's see, all right, our A is 5. So basically, it's just going to, this is going to convert to 5 times EX for the expected value. Right? 5 times expected value. We already have our expected value here, 2.25. So we just substitute. So we're just going to say 2.25, 5 times 2.25. We get 11.25. Right? So I'll repeat again. Whenever you see such an expression here, all they want you to do is Separate the expected value and multiply it by the constant, all right? The constant here was 5. As you can see here, our constant is A, right? So you isolate your constant and multiply it by the expected value. All right, we can go to number 3, all right? EX squared, right? So basically, again, here what's going to happen is our random variables, we're going to square them and multiply them by their probabilities. If you recall, let me just get this formula here. If you recall from when you're getting the variance, this is the same expression we use, and when we simplify it, it becomes this. All right, so it's going to be 1 squared times 0.25, 2 squared times 0.25, and 3 squared times 0.5. And this same symbol, we see it when we're getting our variance. But in this case, we are not tabulating the variance. So 1 squared is 1. 1 times 0.25. 1 times 0.25 plus 2 squared is 4. So 4 times 0.25 and 3 squared is 9. 9 times 0.5. Right, we get 5.75. Right, the next one we have an interesting one. E 6x minus 3. Right, so we have to follow this rule, right? E ax plus b equals a ex. Okay, again, we're just trying to isolate the expected value plus b. In this case, our a is 6, our b is 3. So that's what we're going to do. So we say, right? And these are the rules you should follow when doing such questions, all right? This is basically a rule that you must follow. Even this one here, this is also a rule. Okay. So our a is 6, so we'll say 6 times ex. We already have our expected value, which is ex, minus 3. Our expected value is, how did we get our expected value? It was ex. 2.25, so we say 6 times 2.25 minus 3, right? But we do not need to find the expected value again because we already found it here, right? So 6 times 6, 2.25, that's 13.5. minus 3, that's 10.5. All right, then the next one is E4x squared plus 1. All right, so for this one, all right, we're still going to follow this principle. The only difference, this is going to become ex squared, all right, but the same principle applies. All right, let's put this as squared. So we're going to have 4 times ex squared, and our ex squared, we already tabulated that. Let me get our value for ex squared plus 1. Right, so we already got ex squared here, so we'll say 4 times 5.75, 1. So 4 times 5.75, that's 22.88 plus 1, 23.88. All right, now the next question, we have to find that our probability of our random variable being greater or equal to 2. So when we come here, probability of our random variable being greater or equal to 2, so that means we include the probability of 2 and the probability of 3. So we're going to say that's going to equal to the probability of, it can either be 2 itself, or it can be greater than 2, which is 3 at the moment. So we're adding. The probability of it being 2 is 0.25, our random variable being 2, and the probability of our random variable being 3 is 0.5. 0.25, okay, let me just confirm on our table here. Yes, so 0.25 plus 0.5, 0.75. The next one, the probability that our random variable x is greater than 2, right? So this is just going to include the probability of a random variable being 3. It gives us 0.5. Then the final one, we have the probability of a random variable being greater than 1 but less than 3. So we've come to a table, greater than 1 but less than 3 means the probability has to be 2. So that equals to probability x is 0.25. All right. So see you next time, colleagues. This is how you do these questions.